This is my lab report on the magnetic field of a bar magnet experiment. This lab will use a bar magnet and a phone magnetometer to find the magnet's dipole, and then the magnet's field will be calculated in Python. The purpose of this lab is to observe the relationship between observation distance and the magnitude of magnetic strength. The results of this lab show that the relationship between observation distance and magnitude of magnetic strength can be analyzed by taking the natural log of both sides of the equation and measuring the resulting linear equation, so using the slope and the intercept. The surroundings is the Earth's magnetic field, and the system is the bar magnet and my smartphone and its magnetometer. The experiment was done outside, so there's no interference from like wires and other electronic devices. The experiment is performed in Atlanta, where the Earth's magnetic field is 49 microtesla, and the phone is lined up with magnetic north. This is the spreadsheet I used to get my numbers and where I recorded my results. And this is how I found the value of mu. I set two equations for the B field equal to each other, and I found K by raising e to the power of the natural log, and the natural log and the e will cancel out, which will give me K. And I also have N from my spreadsheet formula, and using that I was able to get mu. We use this formula in the Python code to calculate the field at 8 different observation locations around the magnets. And then we draw arrows along these axes. So the 8 different observation locations are 4 perpendicular, 2 parallel, and 2 at a 45-degree angle. So this is my dipole B formula, which is just an implementation of the formula I showed earlier. And these are the axes that my code printed out. And this is the diagram of the field that my code drew. The cyan arrows are the perpendicular axes, the orange arrows is the parallel axes, and the magenta arrows are the 45-degree angle axes. So some sources of error. I did the experiment outside, and so I didn't do it on a table or anything. I just did it on the asphalt, so the phone was not totally flat. It was difficult to measure how far away the magnet was from the phone's magnetometer because it was hard to, I had to hold the ruler in one hand and the magnet in another hand, and my hand might have moved a little bit. The measured magnetic field rapidly fluctuated within a small range of values, so I got pretty close, but I don't think any of my values were exact. So what if I hadn't oriented the experiment to compensate for magnetic north and instead laid out the meter stick at some intermediate angle? I would have overestimated the strength of the bar magnet because I would have assumed that all of the X was coming from the field in the X direction was coming from the magnet when actually some of it was coming from the Earth. And if I were to stick two identical magnets together end to end and do the same experiment, the results would be pretty similar. It wouldn't like double the power of a magnet to stick two together, but the dipoles would be further apart, so that might have a small effect on the field, but not a really dramatic effect. When the magnetometer was far away, it measured a near zero magnetic field in the X direction. As the magnetometer moves closer to the magnet, the measured X component of the magnetic field increases, and we can plot the natural log of Bx versus the natural log of R to find the constants needed to solve an equation for the value of mu.